Hello and welcome everyone to today's video. What we're going to do today is look at a number of different machines and their print results. Basically, not too long ago we saw a video by MakerBot where they used a so-called tolerance test to test out their Method X printer. Essentially what this tolerance test is you print a pattern of squares and circles, so holes within a plate, and then the holes and squares get progressively bigger from left to right. So the leftmost hole is exactly 10 millimeters in diameter, or 10 millimeters in length for the square. And then it's 10.05 for the next hole along, 10.1, 10.15, 10.2, 10.25, etc. And at the same time, you print little nubs, one round, one square. And then these are exactly 10 millimeters. And then you can go and check which hole they fit into. And that way you can figure out what the tolerance of your printer actually is. And we saw that and we figured, hey, why not do the same thing? We've got a number of printers here and a number of different materials, so let's just try this out for ourselves and actually see what the deal is. So we went and took two fairly expensive printers, the Raise3D Pro3 and the Ultimaker S5. Let's take one slightly less expensive. We've got the WASP Delta 2040 Pro, and then we took one on the somewhat cheaper end with the Creality CR5 Pro. I think that's the full name. Hoping I didn't mess that one up. No, Creality CR5 Pro H. It's the high temperature one. So we've got these four different printers, and now we'll try with several different filaments. We have original manufacturer filaments, so one from Raise3D. We've got Innofill for Ultimaker. We've got the spool of filament that came with the WASP printer, and with Creality, they send a branded PLA along with it as well. We're going to do the whole test with PLA material, and then what was I going to say? And then we have a couple of other filaments. We've got one in black. That is from an Italian company. We've got a green tech extruder, and we've got the Polyterra PLA from Ultimaker. And we'll go through each of these and have a look at the different printers and their results now. All right, I'll be trying to move through the printers in order of ascending price. So the first one we start with is the Creality CR5 Pro H. And as I said, that the material that we started the first print with was the one that came with the Creality printer. So the CR5 Pro H printed this part right here with its branded PLA. And as you can see, the tolerance for the rectangle, or the square peg, is at 0.15 millimeters, and for the round one, it is at 0.2. Now, as you can see, I can just remove the peg and push it back in there without too much force. With some force, I can also get it into the better ones, but it'll take increasing amounts of effort, so this is the one where it fits the best. Same deal, of course, goes for the round one. I can force it into the other ones, but that's the one that it slots into. So 0.15 and 0.2 for the branded material. So then we thought, okay, what if we use a different material? So we went and used a different PLA, and it turns out things got a little worse. This time around we have 0.2 for the square, and it's already really tightly in there. So 0.25 would probably be a little bit more fair if I tried to maintain the same effort of slotting the pegs in there. So let's call that a 0.25, and for the round one, it'll be a 0.3 to have the same effort. Although, yeah, 0.3, I'll call it that one. So you see that the result is slightly worse than previously. There's not much to say here other than apparently material on the Creality makes a small difference, because afterwards we took a green tech PLA and the results got better. So I would say this is more or less a scale of quality. Try not to move that out of the camera view angle. A scale of quality with green tech PLA being the best, then the branded Creality one, and then the third one that we also tried along with it, because the quality keeps getting worse as we get to the cheaper filament, essentially. So what we then did was, what if I changed some of the settings? And I tried printing one of the green tech PLA one, with a slower outer wall speed. I tried to make it better, so I thought I would slow down the outer walls. Instead, it got worse. So I'm not entirely sure why that is, but it is the way it is, and I can't change it. So it seems that the basic settings that were already predetermined in the slicer were actually the better choice. I was wrong to try and make it slower. So that's everything for the Creality for now. The tolerances, while I've been harping on about them a bit, are not bad. These are very, very good. And for the price that the printer is at, it's completely reasonable to expect something like this. Next up, we have the WASP printer, the Delta 2040 Pro. And again, we originally started with the PLA that came in the box along with the printer. And here we have tolerances of 0.1 for both the round and the square peg. Once again, I could try and force them into the even tighter tolerances, but that is a lot of work. And if I had something a little more fragile than this test, I might break my connectors. So we're going to stick with the 0.1 tolerance. That is our result for the out-of-the-box PLA. Then we changed to the Polyterra PLA by Ultimaker, and our tolerance actually improved to 0.05, both for the square and the round peg. Tried again with the GreenTech PLA, which is considerably more expensive. Our results actually got worse. This time around, we're at 0.15 for both the round and the square peg. Now, all of these are better than on the Creality, but that is to be expected. We just went up a significant step in price, so this is more or less what I was expecting to see. I wasn't expecting that GreenTech would be the worst of these options, but that seems to be the way it is. Once again, I tried changing some of the settings, this time making it slower, because the WASP is actually insanely fast. Whereas every other printer in this whole test, so the Raise, the Creality, and the Ultimaker each took between 8 and 11 hours to print this test with the settings that we used, which are basically just the standard settings with 0.1 millimeters layer height. The WASP took 5. It just was almost twice as fast as all the other printers. So we tried slowing it down to bring it a little more in line. And it turns out it changes nothing. The tolerances of the Polyterra remained at 0.05 millimeters. So I guess neither the material, well, the material has a small impact, but the speed doesn't. And the difference here mainly comes from, well, the material, as I said. So let's move on to the next one. Now we have the Ultimaker S5. One of the priciest printers in this lineup, and I expected great things from it because, well, Ultimaker's a name brand, right? So we printed the first part and it came out awful. Used Innofill, and the tolerances were all the way down at 0.35, the worst one of the bunch. I could believe my eyes. So we did it again with a different material, 0.25, marginally better, but still far, far, far away from where everyone else was. I was wondering what the hell is going on. We had used the standard profiles that came with Cura for PLA and set it to fine, so 0.1 millimeters layer height, and just waited to see what happened. This was the result, and that just couldn't be. So we discard those. It's wrong settings, because there are more things in Cura than just that default and then fine setting. Instead, if you go to engineering, it sets the layer height to 0.15, but the results are brilliant. So now, with the white PLA that we also had before, we have 0 for both the square and the round peg. And for the Innofill, we have 0 for the round and 0.105 for the square. That's insane! How can they be this different? Just because in the slicer, I went from default to engineering. I don't know why this is. I don't know what the hell is going on in that slicing software to make such a difference. And in my opinion, it shouldn't happen because, well, the average user won't know that default will give you terrible tolerances, and you really need to enable engineering in order to get proper tolerances and accuracy on your print. So I'm a little confused by this, but it has to be said, this result is stellar, and the Ultimaker did a really, really good job once we had the right settings. So once again, user error, I guess. The problem is always in front of the machine. My fault. My bad, Ultimaker. Once I had the right settings, the results were great. All right, these are the last 2 tests we have, and they're not actually from any printers that were included in this lineup. This one right here is from the Raise3D Pro2, and this one from the Raise3D E2CF. Now the Pro 2 one we chose because it is the predecessor of the Pro 3 that we tested in this whole video. And we wanted to know whether there was a difference going from the older to the newer model in terms of tolerances. Turns out there aren't. For the Pro 2 as well, the square peg fits into the 0 hole and the round one into the 0.05. So there's that. The E2CF is a tiny bit more interesting because it is a printer specifically designed to print fiber-filled filaments. And while those usually feel quite nice on the outside, they are in actuality fairly rough. And that also shows in the tolerances. The square one fits into the 0.15 hole and the round one into the 0.2. This one is a bit, you know, an outlier. We can't change any filaments because the E2CF is fairly locked down, but we wanted, you know, to show this because we were curious, and then we decided to include this. So there you have it. So as you can see, there are a bunch of differences depending on which printer you use, which material you use, and sometimes what settings you use. And when combining all of this, there's a ton of knowledge that you have to have before starting to print. But that's what we do this for, and that's why tests like these can be very, very informative when you get a new material or a new printer. It's just great to know. Let me know what your experiences are. Do you have a 3D printer at home? I'll put the STL and the link to this tolerance test down below in the video description, and then you can try it at home for yourself. And please, tell me in a comment what your results are. Are they better? Are they worse? Have you figured out the perfect settings to get the best tolerances every time? Let me know. It would be great to hear from you. So with that, that's all I have today, and I hope to see you next time. Bye.